Okay, we are starting off our math. So hello to our friends at home. We're starting off with today's lesson is our math packet and working on Khan Academy. So we're just going to go through a little bit of the math packet so we understand how to do it. And then we're going to have work time for the math packet in Khan Academy. We will do Unit 4 retakes on Thursday. So we'll do the practice work and retakes on Thursday in class. So if you're still at home, we will have to do it when you come back to school. So let's look at what we're doing on our first page in the math packet. The first page says, in how many ways can 36 be written as the sum of two prime numbers? So let's break this down. What does sum mean? Zoe? What operation are we doing if we're finding the sum? The sum is the answer, but of what kind of math problem?
Addition.
Not multiplication, not division.
It's an addition.
Oh, addition, yes. So when you're finding the sum, it means you are adding. So that's a key thing to know. We are going to be adding two prime numbers. Who remembers what a prime number is? Will? No? Adrian?
Something that, like, a number that you can't multiply to get to it.
The only factors of it is 1 and itself. It doesn't have any other factors that you can multiply together to get to it. So think about what our prime numbers are that we can add together to equal 36. So in order to do that, we need to know what our prime numbers are. Who can tell me the first prime number?
1.
Not 1.
So what?
Oh, yeah.
Prime numbers start with 2.
Okay.
3.
5.
Is 4 a prime number? I heard somebody say 4. It is not, because 2 times 2 equals 4. So we have 2, 3, 5.
7. 9. Wait, no, 3.
3 times 3 equals 9. So it's not 8, not 9, 10.
Yeah, 10.
No, 2 times 5. 11.
Yes.
12.
No.
No, 3 times 4, 2 times 6. 13.
6 times 2.
Yes.
14.
No.
So what are we noticing? Are any even numbers prime? No, because we can multiply 2 by something for an even number. The only even number that is prime is 2 itself, because you're not multiplying it by 2. All the rest are going to be odd numbers. Is every odd number going to be prime? No, like we saw with 9, 3 times 3 equals 9. So not every odd number, but let's check and see. So we know not 14. What about 15? No, 3 times 5.
Yeah.
What about 16? That's
No.
even. What about 17?
Yes.
Yes. 18 is even. What about 19?
Nope.
What two numbers can we multiply together to get to 19?
Oh,
No, that's
0 and 19.
1 and 19.
Oh, you know what? I'm stupid.
20 is even. What about 21?
nope, because 7 times.
7 and 3. What about 22 is even? 23.
Nope.
23 is prime. 24 is even. 25.
Is not
5 times 5.
Oh.
So not 25. What about 26 is even? 27.
No, we can go 8.
9 times 3 is 27. 28 is even. 29.
We can go into it.
29.
29 is prime. 30 is even. What about 31?
Nope. Yes.
31 is a prime.
I don't know what this is. I
Am
knew it was
am
this.
I saying
but
yes to go up there or yes to not go up there?
I know. We were saying if it's prime or not. So if you say yes, it means it's prime.
I
If
was
you
saying
say
no,
no,
but-
it's not prime.
No, I
But
understand.
you
no.
were saying no, nothing can multiply it. But the question is it prime?
Yes.
So let's all be on the same track. 32 is even, so it is not prime. 33.
No, I can't. Or no, 33, because 11 times.
11 times 3.
Good job,
34. It's even. 35.
Yes. No. Wait, yes.
No,
5 times 7 is 5 times 7 will work, so it's not prime. 36 isn't even. Can we go any higher? No, because we're adding numbers together. So we have to stop when we get to 36 because you can't add something to equal 36 if it's bigger than 36 already. So these are our prime numbers that you're working with. How many ways can you get 36 as your answer? Only using 2 numbers at a time. 2 prime numbers at a time.
And multiplying.
Oh, some. Oh, we are adding.
It says right there. And you
So,
can only use 2 numbers.
What I wrote on the paper, you should have written on your paper. So remind yourself that sum means you are adding. You should have the list of prime numbers that you're working with. Anthony, do you have a question?
Is 0 a prime number?
No, it is not. Our first prime number is 2.
Because like 0 times itself. Like
The first prime number is 2. Shh. Who can tell me one way that we can equal 36 by adding 2 prime numbers? Aiden. That is not the only way. We are not answering this problem together. I gave us one example. You need to find how many more ways you can equal 36 by adding 2 primes together. If we've already used 31 and 5, can we use them again? No. So you can cross them off because you can't use them again. I would look at it and say, 2 plus what equals 36? 2 plus what would equal 36? 34. Is 34 a prime? No, so I can cross 2 off. Work your way through your prime numbers. Starting with the 2, work your way up and see, crossing numbers off as you go, seeing how many ways. Your answer is how many ways can you get?
Answers?
You have to list off every combination. That's why your answer makes sense. Listing off every combination. The answer is the number. There were 7 ways we could make 36. There was 1 way we could make 36. Your answer is how many ways. So you should have 1 number as your answer. How many ways? Our second page, Sally, Fred, and Mickey have read a total of 51 books. Fred has read twice as many as Mickey. Sally has read 15 more books than Mickey. How many books did each person read? When I come to word problems, sometimes I get a little overwhelmed by all the information that they're giving me. And what I found is by diagramming it out, putting it, we call it a bar model, it helps you to see what information they've given you and how to find the answer from it. So I'm going to show you how to do a bar model for this one. So we have Sally, Fred, and Mickey. They've read a total of 51 books. Fred has read twice as many as Mickey, and Sally has read 15 more books than Mickey. So Mickey is my base unit because everybody else is based off of that. So if Mickey is 1 bar, how many bars is Fred going to be? It's going to be 2 bars because he read twice as many. How many bars is Sally going to have?
She had 15 more than me.
So she has 1 bar that equals the same amount that Mickey has plus 15 more. So if we look at this, We have 1, 2, 3, 4 units plus 15 equals our total number of books. How many are 4 units? If 4 units plus 15 equals 51, how many would 4 units be? You know, Nick?
I'm thinking.
If 4 units plus 15 equals 51, now we're getting into algebra. If I don't want that 15 extra books, if I want to subtract my 15 books here so I'm down to just 4 units, where else do I have to subtract those 15 books? Gabby? I have to subtract it from the other side. What is 51 minus 15? Nick?
36.
So if 4 units equals 36, how much is 1 unit?
8.
Anthony?
9.
How did you get that, Anthony?
36 divided by 4.
I need to divide both sides by 4. 36 divided by 4 is 9. So if I know 1 unit is 9, where can I put that in my bar model? Brielle? Yeah, in each unit. 1 unit is 9. So there's 9 here, 9 here, 9 here, 9 here. Oh my. Can we figure out how many books each person read? If you filled in the bar model completely, can you write down the answer?
Yeah.
You should know how many books Sally read, how many books Fred read, and how many books Mickey read. But you actually have to show your work. So if you work out your bar model and you put in all the information as you get it, is it easy to answer the question? When you first look at it, you're going, oh my goodness, Fred has twice as many as Mickey. Sally read 15 more. Sometimes we do the guess and check. And we say, well, maybe Mickey had 12 and then Fred had twice as many, so 12 times 2 would be 24. That's just a lot of guessing. And it takes us a lot longer, unless you have a lucky guess and you guess the right number the first time around. It takes a lot of guessing and checking. This way, did we have to guess it all? No, we did it one step at a time. We did some algebra in there by getting our units down to just 1 unit. And we were able to figure out, if we know 1 unit, we could figure out how many each person read based off of that 1 unit. All right, our next page is our 5-card challenge. We know how to do that. Finding the perimeter and area. We need to remember that we need a number for each line. And it looks like we do actually have a number for each line here. So all numbers are on there for your perimeter. How do we find the area of a goofy shape? There are 2 different ways we could do this. Who can tell me one way we could find the area of this?
We can make it into multiple normal shapes. That way we can find the perimeter of those shapes.
We could break it up into shapes that we know how to find. I mean, there's different ways you could do it. Okay, break it up into rectangles and squares. Another way that I've seen people do it is I've seen people make it into one big rectangle. So find the area of the large rectangle and then subtract out the sections that were missing. So you could do it either way. Break it down into small rectangles and squares and add them together, or make it one large rectangle and subtract out the small squares that don't belong.
Okay.
All right. Next page. The first 5 figures of a pattern are below. Study them and answer the question assigned to your class. So you need to just, Math 6 is completing the table. So we're filling in how many blocks are in figure 1, how many blocks are in figure 2, how many are in figure 3. Find the pattern of how it's increasing and complete the pattern. But you have to find your pattern. That's kind of an easier page, so we're not going to walk through that one. Let's look at this last page. This last page is harder because we need to know our formulas. So let's look at our last page with the formulas. So everybody needs to stop with finding the pattern page. You can do that one later. Let's look at our last page with the formulas. So everybody look at your last page. It says write the formula for the volume of a cone. So everybody's going to write this. Pi r squared h divided by 3. So remember, when we have these things right next to each other, what kind of operation are we doing? When we have pi r squared,
Algebra?
when I say operation, is that adding, subtracting, multiplying, or dividing? Multiplying. When the letters are right next to each other, it means you're multiplying them together. So let's look at what the calculation is going to be. What is pi? What numbers do we use? What number do I use to represent pi? Yes, pi equals 3.14. So that's my first number in my calculation. Then I have r squared. What is r? R is the radius. So I have to look at my circle. My radius is going from the middle of the circle out to the side. What is my radius? 7. So it's 3.14 times 7 squared times h divided by 3. What is h, Nick?
18?
Yeah, it's our height. H is the height. So our height is 18 divided by 3 because it's a cone. We're dividing it by 3. So now we have to ask ourselves, if we're doing PERMDAS and we're following our order of operations, what's the first operation I'm going to do? I have 3.14 times 7 squared times 18 divided by 3. What's the first operation that I do? Are there any parentheses? No. Are there any exponents? Yes. What is my exponent? 7 squared. What is 7 squared? No. 14 would be 7 times 2.
49.
If we're doing an exponent, we're not multiplying it by 2. What are we doing, Aiden?
7 times 7.
Yeah, we're multiplying it by itself 2 times. So 7 squared equals 7 times 7. What is 7 times 7?
49.
49. So I have 3.14 times 49 times, what's 18 divided by 3? Anthony? 6. So the math that I need to do is 3.14 times 49 times 6. That is the volume of our figure. So that answer is going to go right there. Then our math 6 question is, what is the volume of the cylinder that this cone was taken out of? So we need to think, if we had a cylinder going on here that we took this cone out of, what's that volume of the whole cylinder? So we need to know that formula. If we know what the formula of our cone is, can anybody guess what the formula of the cylinder would be? Anthony? Tell me the formula. So what are the letters that I would put in there? Not the numbers that I'm going to plug in. So what I'm going to look at is the cone is taken out of a cylinder. So my cylinder formula is going to be very similar to it, but we're not dividing out any of these areas. We want those areas. So we're going to start off the same way. Pi r squared times h. We're not dividing it by 3 because we're not taking the cone out. We want that full cylinder. So pi r squared times h. So in order to find the volume of the cylinder, you need to do this formula, and you're going to put that answer down there.
Isn't that just the same answer as the volume? Like, aren't they?
What is different between the formula of the cone and the formula of the cylinder?
Oh, 8. Okay, yeah, I get it. H.
We're not dividing it by 3. That's the big difference, because a cone is smaller. We had to divide it by 3. Cylinder is nice and big. So with that, I'm going to say goodbye to our friends at home, and I'm going to answer the phone. Have a wonderful day.